Hello everyone and welcome to this video on introduction to the PLDs, programmable logic device, and first PLD, programmable read-only memory, would be discussed in this video. So let's start our discussion. Today we'll be majorly concentrating on what is a PLD, how to design the given function using of PROM. So PLDs, before we go for the topic discussion, the previous class we have discussed on the memories, virtual memories, cache memories, associative memories, auxiliary memories has been discussed. And today's class we will be discussing on programmable logic read-only memory. This is one of the PLD. So coming to the PLDs, there would be three types of PLDs available. So first of all, what is a PLD? What is a programmable logic device? So it is an IC which is can be programmable according to the given function. So there will be an array of AND gates, there will be an array of OR gates. Whether the AND array is programmable, OR array is programmable, or both are programmable. So that configuration will give you a designed PLD. And whatever the design logic function is there, according to that one, we will be blowing up the fuses or keeping the fuses intact. So this is one of the circuit. Now the first circuit is nothing but AND OR circuit. Here this is an array of AND gates followed by an OR gate array. So this is AND OR circuit. Similarly, this is OR and this is AND gate. AND array followed by OR array, OR AND circuit. Usually when you go for AND OR circuit, we will be getting this AND OR circuit for SOP form, sum of products form, and OR AND circuit for POS form, product of sums. Coming to this one, PLDs are of two types, AND OR circuits which are been programmable. So either AND array is programmable, OR array is programmable. What is that? That is been given over here. So the at the back left right side you can see this is the configuration. So here what we'll be having is that for each of suppose I had enough 4 input AND gate, you would be having a fuses would be there. So between these two you would be having a fuse. So the fuse has to be kept intact or it would be blown away. According to that function it would be there. Suppose this is A, B, C, D roughly under either. If the fuses are intact, that particular letters would be there and it is suppose this is there A and B. Suppose all the fuses are intact, then it would be A, B, C, D. Now this is been connected to one or two functions are connected. Let's say this is x1 and this is x2. This is another coming from one more AND gate which has some 4 inputs over here. These two are being connected to OR gate through the fuses. Let's say this is an OR gate. To this OR gate again you would be having the fuses. The first term is being connected, second term is being connected, or none of the term is being connected. That is given by this one. So this is the programming we will say. The fuses has to be blown away, the fuses has to be kept intact, that is been given. So this is AND programmable AND gate is being shown over here. Programmable OR gate is being shown over here. So whatever the letters are there, whatever the letters has to be included. So the first term, all the fuses are intact. So it is nothing but A, B prime. Second term is B prime, C, D, E prime. Second term, you can see this the fuse is not connected between these two terminals. At the terminal over here, there is no fuse connected. So when no fuse is connected, the term is not been included. This is a B prime and C and E prime. This is similarly this is this. So these are the functions which have been there. And one more thing I want to tell you is that even over here you can represent the same thing in the form of a single line and a gate which has been there and this one. Now the number of inputs to this one is been given by the vertical lines. Suppose over here 6 inputs are there. So one input is the true one, the other one is in the prompt implemented form. B, E bar, C, C bar. Okay. So whichever the term is there, suppose it is we require A, B, C. So you put a cross mark at A, B, and let's say this is C prime. So put a cross mark at C prime. A, B, C prime. Suppose if it is A, B, C, you need to put it up at A cross mark at A and B and C. The same applies for AND gate. So coming to the memories, read-only memory. There are the memories available over here. Read-only memory, programmable logic arrays, programmable array logic, FPGAs, CPLDs. These are all the PLDs we will be having a discussion in. Now coming to the three PLDs, the first one is PROM. The first one is PROM. When you go for the PROM, AND array is fixed. You can't change the AND array. The AND array is not programmable, and the OR array is programmable. Similarly, when you go for PAL, programmable array logic, AND array is programmable. This is programmable, but this is not programmable. Array is fixed one. When you go for PLA, both AND array is programmable, OR array is programmable. So this is the fundamental differences between PROM, PAL, and PLA. Coming to the next one, fundamental programmable logic devices. So the first we'll be discussing on PROM first of all. Then we'll be having the other discussions. So PROM consists of an array of AND gates which are fixed one. Suppose if you are having 3 inputs, you would be having 8 AND gates. 3 inputs, 8 AND gates. 2 inputs, 4 AND gates. So by seeing this one, we can say that when you had n inputs, you would be having 2 power n AND gates, and these are fixed one. Each will give you one term, just like the circuit of this one would be equivalent to a decoder. This would be equivalent to a decoder. And then followed by to this one, you would be having an array of OR gates. So these OR gates are being connected with the fuses. So you would be having those fuses can be kept intact or not. That is good. So usually a ROM is being defined with a size given by number of terms, okay, by the output terms, output gates. So this is when given over here. So here these are nothing but 5 outputs are there. This is the RAM size, and you are having k inputs. K inputs is nothing but address lines. Suppose your address lines is 3, you would be generating 8 terms. Okay, 8 terms would be generated. If your address lines is 4, you would be generating 16 terms. 16 terms. So that is the difference between this one. So 3 inputs, so you can see this example, 3 inputs are there, 8 address lines, 8 words can be stored using of 3 address lines, and each output word is of 4 bits value. So this is one of the example of an ROM. You can see 3 address lines, and these are the outputs. So the same thing you can represent in the decoder style, or I can represent this one. So here D1 output is what, D2 output is what. A very simple example is this one. First you take a decoder, 3 inputs are there. So 3 cross 8 decoder, you take it up. So 8 outputs you will be having it up. Take the 8 outputs, 4, 5, 6, 7, 8. I'm taking very roughly. So from each one, you can take the number of outputs is nothing but you are having each output is what? D1, D2, D3, D4. So 4 outputs, D1, then you take it up, sorry, this is not there, D2, D3, D4. Like that way you take 4 outputs, then you will get. And this is 3 to line 8 decoder. Either you can draw the decoder circuit, I can do. So for example, this is one of the circuit we can see that I have connected. Suppose you had on 4 functions. The first function is given f1 is equal to summation of 0, 1, 2, 3. f2 is equal to summation of 2, 3, 4, 5. f3 is equal to summation of 5, 6, 7. f4 is equal to summation of 1, 5, 6, 7. So when you take it up this one, so what each term is been a line is been there over here. It is in a connection over here. From each of these terms, you will be having a connection. This is for the second one. This is for the third one. This is for the fourth one. This is for the fifth one. This line is for the sixth one. This line is for the seventh one. And this line is for the eighth one. So you can have this. Similarly, the same applies for here also. It would be the first connection, second connection, third connection is this one. Like that way, all the gates are the lines are representing one of the product. This was 0 product term like that. Now these vertical lines represent the AND function. So when you take f1, f1 is 0, 1, 2, 3. So the 0th line is this one. So the fuse between these two is intact. We are not blowing away the fuse. At the first, all the fuses are intact, but when you go for the programming, we will blow up the fuses. But here, for your explanation, what I will do is that which fuses are to be intact, I will draw a line, and which fuses are to be blown away, I won't draw any line between them. So here, 0, 1, 2, and 3. These 4 fuses are intact for the first function. Second function is what? This 0 line, the 1, and this is 2. 2 is intact, 3 is intact, 4 and 5. Remaining all fuses are blown away. Now coming to the third one, 5, 6, 7. This is 5, this is 6, and this 7. 3 fuses are intact. And for this one, 1, and then 5, 6, 7. So these are the 4 fuses intact. All this one would be the programming concept, how you go for the PLA program, PROM program. Very simple. Again, the same thing you can represent over here also. Here, this is the another function. Now, can you tell me the functions for this one? Now, coming to the first one, D1 is a summation of, you can write over here D1. I will write over here. D1 is a summation of, what are the terms over here? You can see 0, 1, 2, 3, 7. Wherever the 0, 1, 2, 3, 7. And D2 is a summation of, what are the terms over here? 1, 2, 3, and 5. 1, 2, 3, and 5. When you go for the D3, D3 is a summation of 0, 1, 2, 3, 4, then we do, 4 is not there, 3, then 5, 6. And D4 is a summation of, you had 1, 3, and 6. So you can represent this one. Even if you have given this one, you can go for that. This is the simple way. The cross point is that this product term is being included over here. Now, how many input OR gate is this one? 8 input OR gate. And now how many fuses are intact? 3 fuses for D4. How many are there for D3? D3 is having 6 fuses intact. Like that way you will be having. So this is about the implementation. Now you can go for full adder circuit implementation using of PROM. Very simple. 3 inputs. You will be having 8 product terms you will be getting. One is a sum, one other is a carry. So 2 OR gates are not in use. So you will be having one sum and one carry. That is the cross marks for the sum and carry which have been shown over here. So we can implement any logic design. You can go ahead. This is an input, this is an output. This is nothing but squaring a number. You can have the 0 to 1 square. So you can generate that output also very easily. So this is a square of a number example. I hope you have understood this.